go back and see it later. I'll be posting on the Google Classroom shortly after we finish up here tonight. All right, let's see. Where are we going? There it is. All right, so here we are in week 6 of this class. Ooh, got a bunch of random stuff up here. Don't need this stuff. So that means we only have a couple more weeks left of term 5 and of the school year in total. So we've got the rest of this week, we've got all of next week, and then we have 3 days of the following week, Monday, Tuesday, and Wednesday next week. But our last day of class is May 26th. So if you look at our actual class days, our actual days that we're going to be meeting together after this, we only have 4 more days after today that we're going to meet together as a class before the end of a school year. So we are getting there, and we are getting there fast. So like I said, today we're going to be talking about how scientists measure the world around them and what are some of the basic measurements that they take. A lot of these measurements deal with what are called SI units. It stands for International System. You might also sometimes hear it referred to as the metric system or metric units. And these are the units, these are the measurements that scientists like to take for a number of different reasons that we'll talk about today. So they are different from the normal, like American system of measurements. So there's no pounds or feet or inches or anything like that. Instead, it's this different series of units, these SI units, or the metric system. So today we're going to talk about what are the 3 major types of measurements that scientists make, and how can we convert between larger and smaller or smaller and larger sizes. So the first part where we talk about the units, what we actually use to measure. For the first type of measurement is length. And length could be like length or height or distance or width, any sort of measurement of like distance or length, how high or how tall or how far something went. That is all length. So in the American system, you might use miles to describe how far you drove in your car, or you might use feet to describe how tall somebody is, or you might use inches to describe how big like a photo is, like a printed out picture. In science, in the metric system, we don't use those measurements. We use things like kilometers and meters and centimeters. So a kilometer is a little over half a mile long. So there's 1.6 kilometers in 1 full mile. Centimeters are a little bit smaller than inches. So there's about 2.5 centimeters for a single inch. And a meter is pretty close to a yard. So a meter is only a little bit longer than a yard is. So kilometer, meter, centimeter, you may have noticed that these all sound a little bit like each other. And they're all based around what we call the base unit, the base metric unit for length or distance, which is meter. So a meter, like I said, it's pretty close to the size of a yard. And that is sort of like our main starting point for our metric system unit of length. So it's usually represented by m, so like a lowercase m. So like if you see 4m written, that means 4 meters. Kind of like you'd use ft for feet or in for inch. In the metric system for meter, we use m. So meter is our base unit, what we call the basic unit of length. If we put 1,000 meters and we line them all up one after the other and stretch it all out, you'll end up with a kilometer. So kilo in science in the metric system means 1,000. So kilometer is also sometimes kilometer, but it's 1,000 meters. So it's usually represented by the letters km. And again, a meter is about a yard. You put 1,000 meters together and you get a kilometer, which is a little over half a mile. It's like 0.6 something miles. If instead you break up this meter into 100 individual pieces, you'll get 100 centimeters. So each meter stick is divided up into 100 centimeters. So you put 100 centimeters together, you get a meter. Again, centimeter or cm. If you want to go even smaller than that, you can look at millimeters. So 1,000 millimeters go into a meter. So 1,000 little individual pieces that make up 1 meter. And we usually represent them with mm. So again, centimeter is about a little less than half an inch. And then 1,000 of them, or 1,000 millimeters are what make up a meter. So like on our meter stick over here, these big numbered dashes. So here, up here is our inches, right? So 0, 1, 2 inches. Down here is our centimeters. So the big numbered dashes are our centimeters. And then the little tiny dashes in here are our millimeters. So every single one of those dashes is the space of 1 millimeter. So millimeter, pretty small.
So how big is a kilometer?
A kilometer is 1,000 meters, which is a little over 0.6 miles, I believe.
0.6 miles? Okay.
Yeah. So half a mile and a little bit extra will get you to about a kilometer.
I have a question.
Yeah.
Do they not count inches?
So in the metric system, in the SI system, we don't use inches. We use kilometers, centimeters, millimeters, and meters.
Can I ask why?
You sure can. So probably one of the biggest reasons, the nicest reason, is that when you're measuring things with, let's say, length in inches, right? You have a mile. And does anybody know off the top of their head how many feet are in the mile? Can anybody tell me right now how many feet are in a mile? Yeah, it's a little tricky, right? I think it's 5,280. So we've got 5,280 feet in a mile. We've got 3 feet in a yard. We've got 12 inches in a foot. All these numbers are all over the place, right? If we want to go from feet to inches, we have to multiply by 12. If we want to go from yards to miles, we have to divide by, I think it's like 100 something yards in a mile. It's a lot to keep track of, and it makes converting between inches and feet and miles really tricky and not line up very well. On the other hand, the metric system, a kilometer, 1,000 meters. A meter, 100 centimeters. Super easy conversions between the different types of units. And later today, we'll actually be looking at exactly how to convert. But so if you have 3 miles, it's probably pretty hard to tell me how many feet that is. If you have 3 kilometers, that's 1,000 meters. If you have 200 centimeters, that's 2 meters. So it's all based on tens, hundreds, and thousands, right? And since we use a base 10 series of our numbers, like it goes 0 through 9, and then 10 through 19, and 21, or 20 through 29, it's really easy for us to convert between tens. All you're doing is adding or taking away zeros on the end of your number. So that is why the metric system is used by scientists is because it makes converting between the different measurements, the different sizes, really, really easy, clear, simple, and straightforward. It also makes things a lot easier when you're going down into smaller and smaller numbers, right? We don't really have anything smaller than an inch in our system, right? Then you start getting into, oh, then you have a half inch, and you have a quarter inch, and you have an eighth inch, and you have a 16th inch, and you have a 32nd inch. It just keeps getting these smaller halves and halves and halves. With the metric system, we can go, so a meter is 1,000 millimeters. 1 millimeter is 1,000 nanometers. I think that's right. So we also have things like, we can go even smaller than millimeters. We can have micrometers and millimeter, or not millimeter, micrometers, nanometers. And it all is just 10 or 100 or 1,000 smaller than our original meter or centimeter or millimeter. Also, the naming stays all the same, right? Kilometer, centimeter, millimeter. Instead of inch, foot, yard, mile. It's all very standardized and it's all the same. And you'll see we'll use these same kilo and milli prefixes for our other measurements as well. So great question, and that was a long way to say it is much easier to deal with than the American system. We like the American system because we're used to it. That's normally how we talk about things in miles and feet and inches. But the metric system is a lot easier to use. And it's used by more people around the world. Only America and some American colonies and a few other countries use the imperial system or the American system for everything. Like 90 or 95% of the countries in the world already use the metric system as their normal system. So it makes it a lot easier for scientists to talk with one another if they're all talking about the same units. All right. So that was a great question about why we even have this metric system. Because it's nice, it's simple to use, and everybody understands it. So length, distance, it's all measured in types of meters represented by m. We can also measure other things like mass, how heavy that objects are. In the American system, we'd use things like pounds and ounces and tons. In the metric system, instead, we use things like grams and kilograms and milligrams, right? So a kilogram is a little over 2 pounds. A gram is like about similar to an ounce or so. So our basic unit in the metric system of mass, of weight, is the gram, usually represented by a little g right here. So 1 single gram is pretty small. It's about the weight of, like, I don't know, a paper clip or a hair tie or like a pen cap is probably about a gram or so. So gram is a pretty small unit of weight. If we put 1,000 grams together, we get a kilogram. Oh, hey, there's that kilo again. Kilogram, 1,000 grams. So kg, kilogram, for 1,000 grams. So a kilogram is a little bit over 2 pounds. I usually like to think of it as about the size of, actually, I think I have something. Oh, there it is. Give me a second. So about the weight of like a school textbook, right? This big science book right here, it's pretty heavy, it's pretty hefty. You've probably held a textbook like this at some point in your life. These guys probably weigh about 1 kilogram. So a little bit over 2 pounds gets us a kilogram, aka 1,000 grams. So if a gram is like the weight of a paper clip, A gram is made up of 1,000 milligrams. So milligrams, or mgs, are very, very, very small units of weight. If you think about in your normal, like aspirin or Tylenol or Advil or something like that, there can be up to 200, 300, 400 milligrams of medicine in that one tiny little capsule that you swallow with your water. So that little thing can have 300, 400 milligrams of medicine inside of it. So 1 milligram is really, 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 really small and light. Again, there's that milli again, just like we had before. Milligrams means 1,000th of a gram. So 1,000 of them make a gram. And then 1,000 grams make a kilogram. Again, super easy, right? 1 kilogram, 1,000 grams. 1 gram, 1,000 milligrams. No 12 to 3 to 5,000, all based on tens, hundreds, and thousands. So that is our mass unit, the gram, or G. So we have how wide or how tall something is, or how far away something is. We have how heavy something is. So our final basic measurement is volume. How much space does something take up? So in English and American units, we would probably use things like fluid ounces or pints or gallons. In the metric system, we don't deal with these. We have things like milliliters and liters. So a liter is very similar to a quart. So a quart, if you remember, is 1/4 of a gallon. So like the really thin, skinny bottles that you see in like the milk section are quarts. And so a liter and a quart are very similar. So there's 3.8 liters in a gallon. So there's almost 4 liters in a gallon, similar to quarts. And then liters are actually the one out of all of these that you've probably had some experience from before. Because if you go to the store, like H-E-B, and want to buy a big bottle of Coke, it comes in 1 or 2 or 3 liter bottles. So if you think about like the really big plastic bottle of soda that you can get at the store, that would be like a 2 or 3 liter bottle. So liters are our base unit. They're usually represented by an L, either a little L or a big L. I personally like using the big L just because it makes it clear that it's an L and not a 1, which can sometimes happen with this guy. These are used a lot for liquid volumes. For solid volumes, we can use things like centimeters cubed or cubic centimeters. So that's what this little CM3 represents here. And so it's a 3 because we're measuring volume in 3 dimensions, right? Height, width, length. So if you're ever buying like furniture or something from a store and you want to know if it fits in your room, it'll usually give you the 3 dimensions of that furniture. So you know how tall it is, how wide it is, and how far back it goes. So that's what the 3 in centimeters cubed stands for. Is if we have a box like this, it could be 10 centimeters tall and 10 centimeters wide and 10 centimeters deep. So to find the volume, you'd multiply them all together and get 1,000 cubic centimeters of volume. For the most part, we're going to stick with liters and milliliters for volume, but you might see cubic centimeters pop up every now and then. So like I said, 1 liter, if you think about kind of the skinny size bottles, like the bigger size, but they're still kind of small, that's a liter. And it's made up of, what do you know, 1,000 milliliters. So there's our milli again, or 1,000 mils, mLs. So a milliliter, if there's 1,000 of them in a liter, 1 single liter, A milliliter is pretty small. I usually think of a milliliter as about the size of like a single drop of water from like an eyedropper or a single raindrop falling from the sky. Those are usually somewhat close to 1 milliliter. You put 1,000 of those drops together and you get 1 liter. So we have meters, grams, and liters as our base units. They're how we measure height and distance. They're how we measure weight, and they're how we measure volume. And then all of our other units are based around these 3. So we could have, for meters, we could have kilometers, centimeters, and millimeters. For grams, we could have kilograms or milligrams. For liters, we could have milliliters. It's all based on these series of hundreds and thousands, and it's all based around those base units: grams, meters, and liters. All right. Anybody have any questions about these metric units so far? Anything that you're a little bit curious about or that you want to know more about regarding these 3 metric units?
No.
Yes, so to determine the amount of, so why would they do the 10 centimeter cube for the liters?
So, there we go. So liters are usually used for like liquid measurements. Like, I don't know, like in Europe, they usually measure like the amount of gas that you get at a gas station in liters, not in gallons. So liters and milliliters are used for liquids a lot, but then solids, so physical solid objects, we usually don't necessarily measure them by liters. We'll measure them in cubic centimeters, or if it's like a really big object, it could also be cubic meters as well. So it's a different way of, it's the same type of measurement. You're still measuring the amount of space that an object takes up. It's still volume, but it's a different way of measuring volume based on its solid volume, not necessarily its liquid volume. So you could fill up this box. If it was like a shipping box and you could open it up at the top, you could fill it up with liquid and measure how much liquid fit inside of the box. But if it's like a solid cube or something like that, you can't really put anything into it to fill it up. What you can do is measure the height, width, and depth, and then multiply those together and give you the solid volume. And you're probably going to measure those in centimeters or meters, like we were talking about earlier. So that's where this centimeter cubed comes from.
As for the solid volume. Okay, cool.
Exactly. Great question. So,
And also, well, I have
go for it.
a question. And also, like you said, the meters, like 95% of the world use that metric system. Does that go for the same for this metric unit and the other one before that?
Yep, all of them are all counted as part of the metric system. So liters and grams and meters all fall under the metric system. And that system with those 3 measurements and some of the other ones we'll talk about later on in the term, those are used pretty consistently throughout the rest of the world. So it's only America and a small handful of other countries that use like feet and miles and inches and pounds and ounces and stuff like that. Most of the world uses grams, liters, meters. And again, it all comes down to simplicity, right? With weight, we have pounds, and then we don't really have much things bigger than pounds until you get up to tons, which is 2,000 pounds. Or if you want to go smaller, then you have ounces. But I don't even know for sure. I think it's 16 ounces makes 1 pound. Why is it 16? I don't know, just because. Grams, 1,000 grams to a kilogram, 1,000 milligrams in a gram. And then same thing with volume. There's 2 cups and a pint, and there's 2 pints in a quart, and there's 4 quarts in a gallon. That's a lot to keep track of. You can also just know in 1 liter, there's 1,000 milliliters. So ease of converting between them is why a lot of people use the metric system. So doing these metric conversions, one of the reasons why it's so nice to use the metric system is a lot easier than converting between the American system of measurements, but it still takes a little bit of practice. And so the kind of second thing, and the thing that we're going to spend the rest of tonight talking about, is this method that I've found and that I've used that makes learning how to convert between the different sizes of metric unit very, very easily. So if you have grams and you want to know how many kilograms you have, if you have centimeters and you want to know how many millimeters that you have, you're going to go through these metric conversions. So going from a larger size unit to a smaller size unit, or other way around, going from smaller to larger. So the way that I've found to be really helpful, and something that I know a lot of students have found to kind of use easily to transfer from one to the other, is something called the ladder method, also sometimes called like the stairs or the stair step method. And it looks a little bit like this. So here we have the ladder of all of our units that we've just been talking about. Some of these you don't really need to know, like kilo, very important. We talked a lot about that one. Hecto and deca, not really used as much, pretty uncommon. We still need them to be there for reasons that we'll see in a second, but you don't really have to know about them. Our base unit, also very important. So anytime that you're dealing with just meters, just liters, and just grams, that's when you have a base unit. So not centimeters, not milliliters, not kilograms, but just meter, gram, liter. That's a base unit. Deci, again, don't really worry about that one. And then here is our centi, like centimeter. And here is our milli, like milligram or milliliter. So every type of measurement is represented here. And we're going to use this to figure out how to convert from one size to the other. So there's 3 steps that you go through to figure out your conversion. The first one is find where's your starting point and where's your ending point. So we'll do this example over here. We'll use this as kind of like our starting example. I have 4 kilometers. I've taken a 4-kilometer measurement, and I want to know how many meters is that? How many meters are in 4 kilometers? So my starting point is kilometer, kilometer, kilo over here. So this starts with K. So I'm going to kilo for my starting point. And then my ending point, meter, that's one of my base units over here. So meters is a basic unit. So I'm going to start at kilo. I'm going to end at the base unit. Next up, figure out your direction and jump from your starting to your ending point. So we're going from kilometers to meters. So we're going to the right. Okay, we're starting over here and we're going to the right this way. And we're going to jump 1, 2, 3 spaces to the right. It's kind of like if you're playing a board game and you roll a 3 on the dice and you get to move your little person 3 steps. Very similar thing happening here. We're starting at kilo and we're counting 1, 2, 3 steps over to our basic unit. So to go from kilo to meter, I took 3 steps to the right. So the third thing that we have to do for the ladder method is then take our number at the starting point. We're going to take the decimal point and move it the same direction and the same number of steps as we jumped on the ladder. So on the ladder, we jumped 3 steps to the right. So if I have 4 kilometers, I'm going to take my decimal point, which, since this is a whole number that doesn't already have any decimals in it, the decimal point is right behind the 4. And we're going to make 3 jumps to the right. 1, 2, 3. We're left with these 3 blank spaces here. And the rule for these unit conversions, the rule for the ladder method, says that whenever you have a blank space left by your decimal point, fill it in with a 0. So we started with a decimal point here. We made 1 jump, so we're going to have a 0 here. We made 2 jumps, so we're going to have a 0 here. We made a third and final jump, we're going to have a 0 here. So now, instead of having 4 decimal point, I have 4 with 3 zeros and then the decimal point. So that tells me that 4 kilometers is 4,000 meters. I started with my decimal point right here, and I moved it 1, 2, 3 spots to the right. So now my decimal point is right here. And I fill in all those empty spaces with zeros. So 4 kilometers, after you move that decimal point 3 spots, becomes 4,000 meters. So we started up here and jumped 3 to the right. And that told me that I'm going to take my decimal point and jump it 3 to the right. So those are the 3 steps of using the ladder method. Figure out your starting and ending points. Figure out which direction and how many jumps it takes to go from your start to your end. And then do that same number of jumps in that same direction with your decimal point. So in this case, we were jumping to the right and it gave us a bigger number. Sometimes, like if you're going from centimeter to basic, you're jumping to the left and giving a smaller number. You're moving the decimal the other way. Whatever way you move, whatever way you move on the ladder, that's how you move your decimal point. All right, so we'll do a whole bunch more examples of those with you, and I'll have you guys help me out with a couple of examples to make sure everybody really gets it. But is anybody totally lost so far? Is anybody really confused about where any of this stuff came from?
No, but go ahead.
No, you go. Go ahead.
Okay, thank you, sir. So it's not confusing. I get the jumping points and the going down the ladder or up the ladder. But right here on this screen that I'm looking at, I'm pretty sure you're going to get to it to convert to a smaller unit, move decimal point to the right or multiply, and then the larger unit left or divide. That's like I've been looking at that the whole time while you're doing this and also like learning that, but I don't get that part when you're talking about the decimal points to the right or to the left of the number. Am I making sense with this question?
Kind of, yeah. So you're saying like this says to convert smaller unit, move the decimal point to the right.
Yeah, but whenever you just explained it right now to, you got 4 kilometers, and I guess that's just to determine how many meters are in there. But it seems like that's the bigger number, right? Or how are you convert
Exactly. So this is
that example?
to convert to a smaller number. So we're going from kilo, which is big, to meters, smaller.
Oh, okay, got you. Sorry.
So meters is a smaller unit, right? A meter is smaller than a kilometer, but it's going to give us a bigger number because 4 kilometers, we have 4 sets of 1,000 meters. So there's going to be 4,000 meters in a kilometer. So that's what it means by this point. It means that we're converting it to a smaller unit. So we're going from the bigger size to the smaller size. So when you do that, you move the decimal to the right, or go from a smaller size unit, like a milli or a centi, to a bigger size, like a basic or a kilo, you move the decimal to the left.
I get it now. I see it. I was just like reading it and the numbers and stuff. So
Yeah. It's a smaller unit, but it'll give us a bigger
number. Yeah. Got it. Thank you.
Sure thing. All right, Eloisa, what was your question?
Oh, mine had to do with, no, I think I understand this, but I was going to ask, are you going to do like a review about what we learned on, I think it was Thursday?
Not really, mostly because it's not something that's going to be on the final. Like I purposely didn't put it on the final since I know it's pretty confusing for people. And the homework for it was a completion grade, meaning that as long as you got it turned in, even if some of your answers weren't right, you still got full credit.
Okay, so but is there like a STAR test for this class or no?
Nope.
Oh, okay, that's what I was worried about. Okay.
Oh, okay, yeah. Nope, the only STAR test is for biology, and I've never seen any balancing chemical equation questions on the biology STAR test.
Okay.
Okay, gotcha. No worries. All right, let's do a couple more of these examples just to make sure that everybody's got them down. I'll do kind of a couple to show you guys at first, and then I'll have you guys help me out with a couple as well. All right, so let's see if the answers that they're giving us right here actually match up with the correct answer. So, let's do this one first because I like this one. So this says that they're telling us 1.6 liters is supposed to equal up to 1,600 milliliters. I want to double check and see if they're right here. So we're going from liters to milliliters. Liters is one of our basic unit. So remember, liters and grams and meters are our base units. So liters, basic unit, and milliliter is our ending unit. So we're starting at liters, going to milliliters. We're going to the right, and we are going to jump 1, 2, 3 steps to the right. So 3 jumps to the right on our ladder means we're going to take this decimal point and move it 3 jumps to the right on our number. Luckily for us, on this example, they show us exactly where the decimal point is. It's between the 1 and the 6. So for most of these numbers and a lot of the ones in your homework, you're going to be dealing with the decimal that's at the end of the number. But sometimes you get one that's right in the middle like this. So 1.6 liters, we said we're going to jump 1, 2, 3 to the right. So we take this decimal point and we go 1, 2, 3 jumps to the right. So it's kind of hard to see because I can't actually write on these slides, but that gives us a 6 and then a blank space, which is a 0. And then the third jump gives us another blank space, which is a 0. So now, instead of having 1.6 liters, our decimal point is over here, and we have 1600 liters. So 1.6 liters is indeed equal to 1600 milliliters, or 1600 milliliters. We said 3 jumps to the right. Our decimal point started right here. So we'll jump 1, 2, 3 jumps to the right. All right, let's see. Oh, here's a good one going a little bit different way. I have 109 grams. So remember, gram is a base unit right here. And I want to know how many kilograms do I have. So this says that that's supposed to equal 0.109 kilograms. But I'm going to double check and make sure this is right. So gram is a basic unit. Kilogram is kilogram. K for kilo means that we're up here in the kilo zone. And to go from grams to kilograms, I'm going to jump 1, 2, 3 jumps to the left. So we're going opposite. We're going backwards this time. 1, 2, 3 jumps to the left to go from basic to kilo. So we start off with 109 grams. The decimal point is right here. So we're going to do 1, 2, 3 jumps to the left. Now the decimal point is no longer after the 9. It is in front of the 1. So we no longer have 109 grams. Instead, that is equal to 0.109 kilograms. So the decimal started over here. We jumped 1, 2, 3 to the left. And the decimal point was put in front of the 1. So we now have 0.109 kilograms. All right, let's do the one more of these for fun. Okay, I like this one. So I have 160 centimeters, and I want to know how many millimeters do I got. So centimeters, centi, is right here. And millimeters, milli, is right here. So these guys are buddies. They're right next to each other. So if we start at centimeters, we have to do 1 jump to the right in order to get to millimeters. So we had 160 centimeters, where our decimal point was right here. We're going to make 1 jump to the right. We're going to fill in that 1 blank space with the 0. So now we don't have 160 centimeters. We have 1600 millimeters. So we now have 1600 millimeters. Decimal point started here, and then it jumped 1 to the right. We filled in that blank with a 0. So 160 centimeters is the same thing as 1,600 millimeters, or 1,600 millimeters. So find your starting and ending points. Jump from the start point to the end point in either the right or left direction, and then move your decimal place that many jumps in that direction, whether it's 2 jumps to the left or 3 jumps to the right or whatever it might be. Whatever jumps you do in the direction on the ladder, that's the number of jumps that you do with the decimal.
I'm confused. Can you tell me how do we, okay, so like the 160, it doesn't show where the decimal is. So how do we find out where it's supposed to be?
So if you have a whole number, like, well, all of these besides this guy. So this guy is the only one with a decimal in it, right? 1.6. All these other guys are whole numbers. They don't have decimals. So in these cases, the decimal is always right at the end of the number.
Okay.
You leave it out when you're writing down a number, because if there's not a decimal point, a decimal place, then you don't need to put it in there. but it's still there. It's kind of heading out invisible right at the end here. So this would be 160 decimal. This would be 1000 decimal point. This would be 14 decimal point. If it else, you could also think of this as like 250.0, 250.0, if that helps you kind of think about where the decimal point should be.
Okay, got it. Thank you.
No worries. So yeah, so for numbers that look like this, you always start with the decimal point right at the end of the last number. All right, great question. Any other questions, comments, concerns before I have you guys help me out with a couple examples?
No.
All right, so what I'm going to do is I'm going to bring up a online whiteboard here. Let's see, where's the button for that? I think it's over here. There it is. There we go. You send. And then share that guy. There we go. So the first thing that I'm going to do here is make myself kind of a little makeshift ladder. Just everybody keep on track. So we have K for kilo, and then we have those 2 that we don't really need to worry about. And then we have the base unit. And then we have that one more that we don't really need to worry about. And then we have centi, like centimeters. And milli, like millimeters or milligrams. So here is our very rough and tumble ladder. So I'm gonna think of a couple of examples and have you guys kind of point me in the way to go. So let's start off with, oh, I know a good one. I have 77 centimeters. And I want to know how many meters is that? So how many meters are in 77 centimeters? So first thing that we got to do, I'm going to do like blue this time. Sounds good. First thing that we got to do is figure out our starting position. So if I'm starting off with 77 centimeters, which one of these boxes am I going to start at? Feel free to answer out loud or in the chat.
The C.
The C, bingo. Centimeters is for C. Centi, it's this guy right here. Here is our, I'm going to write S for a starting point. And then if I want to know how many meters that I have, which one of these boxes is for the meters?
Basic units box.
Exactly. Basic unit box. So meters, grams, and liters all fall under the base units. So over here, this guy is my ending position. So I'm going to start here. I'm going to end over here. What direction am I going to jump in? Am I going to jump to the right or am I going to jump to the left?
The left.
Left.
Left, exactly. And how many spaces to the left do I have to jump to go from centimeters to meters?
2.
2.
2, precisely. So we're starting off at centimeters, and we're going to go 1, 2 jumps to the left to get to meters, which is our base unit.
Hey, baby.
So we're going to jump 2 jumps to the left. So if we start with our decimal point right here, in this case, and we jump 2, that's 1 jump, and that's 2 jumps to the left. Going left. How many meters do I have if I have 77 centimeters?
0.77 milliliters.
0.77 meters. 0.77 meters. You can also think of it as 0.77 meters too. I like to put the 0 because I don't like leaving the decimal point all out on its own. But you don't have to. They mean the exact same thing. 77 centimeters is equal to 0.77 meters. So we figured out what our starting and ending points were. We determined how many jumps in what direction that we had to go. And then we did that with our decimal point down here. All right. I'm going to erase these guys down here, but then keep my ladder up there so that I don't have to remake it every time. All right. Let's see here. Oh, got a little bit more to erase. And don't need these jumps anymore. All right. Let me think. Other good example. Ooh, okay. Just thought of one. I have 9 grams. And I want to know how many kilograms is that? So I want to convert 9 grams into that same amount, but in kilograms. So let's do green this time. So first thing that we have to do is figure out our starting and ending point. So if we're starting with 9 grams, then which of these boxes, which of these ladder steps is our starting point?
The base.
The base, exactly. Grams is base, just like meters and liters. So the base is going to be our starting point. And then if we're going to kilograms, what is our ending point?
Number 1, kilograms.
The first box over here, K, is for kilo, and kilo is in kilograms. So our first box over here is our ending point. So start at the base unit of grams, and at the largest unit that we're working with, kilograms. So what direction do we have to jump to go from base to kilo?
You can go left.
Base is right here, kilo's over here, and so we're going to jump to the left. And how many jumps to the left do we have to do to go from our base unit to our kilo unit?
3.
3 jumps to the left. So we start right here, and we're going to go 1, and we're going to go 2, and we're going to go 3. So it's 3 jumps to go from grams to kilograms, to go from our base unit to our ending unit. So if we have 9 grams, our decimal point is right here. So we're going to jump 1 2, 3 jumps to the left. And what is the rule for these blank spaces right here? What are we going to do with those?
Zeros.
Those guys get filled in with zeros. So if we have 9 grams, how many kilograms do we have?
0.009.
Precisely. 9 grams is the same thing as 0.009 kilograms, or 0.009, if you like to put the 0 out in front, like I do sometimes. So again, same exact process. Figure out starting and ending points, count your jumps and the direction, and then do that same thing with your decimal point. All right, so you guys seem to be doing pretty well with this so far. So I'm going to give you a little bit tricky one to do. Oh, got a little bit left up at the top here. Bye-bye. All right. If I have .18 kilometers, I want to know how many millimeters do I have? So, changing it up a little bit, not going through some of the usual ones that we do, but I want to know 2.18 kilometers. What is that in millimeters? So, what do we do first? Find our start and end point. So let's do red this time. So we're starting off with kilometers. So which box is going to be our starting box?
The K kilo box.
Kilometer starts with K for kilo, and K for kilo is up here. So this guy is going to be our starting point. And then if we're going to millimeters, which box is our ending point?
The last one.
Chris, the last one, our little m over here. So this little m is for milli, like milliliters or milligrams or millimeters. So this is our ending point right here. So we're starting off way over here at kilometers, and we're ending way over here at millimeters. So if we're going to jump from our start to our ending point, which direction are we going to jump in?
The right.
We're going to jump to the right. And how many steps are we going to jump?
6.
Ooh, 6. Okay, I think that's right, but let me double check here. I always like counting these things out. So we're starting off at kilo, and we're going 1, 2, 3, 4, 5, 6 steps down to milli. So we're going to be jumping 6 steps to the right. So we take our decimal point luckily this time, since this is not a whole number, this is a decimal number, the decimal point isn't at the end of the number over here. Instead, it shows us exactly where our decimal point is right here. So we're going to go 1 past 1, 2 past 8, 3, 4, 5, 6. So our poor little decimal point is moving all the way out here. So we've got the 1 and we've got the 8. We also got a whole bunch of these blank spaces right here. And what do we do when we have blank spaces?
Put zeros.
Fill them up.
Fill them in with a 0. So we're going to have a 0, 0, 0, and a 0. So 2.18 kilometers is the same as 218,000 millimeters. So let's see. Put right there. So 2.18 kilometers is the same as 2,180,000 millimeters. So again, big number, we're dealing with big jumps this time, but we followed the exact same process. Figure out the starting point, figure out the ending point, count the jumps, count the direction, and then do that same thing with your decimal point. In this case, our decimal point jumped 6 times. So we got 1 and then 8 and then followed by 4 more zeros. So 218, 4 zeros is 2,180,000 millimeters. All right, so no matter what your starting value is and what your ending value is, you're always going to follow those steps. And assuming that you do your counting right and you count your decimal right, then you'll always end up with the correct answer. Again, the only thing that'll change in the numbers that you have will be where that decimal is and how many zeros are at the end. If you're going to the right, then in general, you're going to be adding on zeros. If you're going to the left, then in general, you're going to be taking away zeros or putting zeros in the front of the number, like we saw when we had that 9 that turned into 0.009 from that first example. So whether you're adding zeros on at the end, taking zeros away from the end, or adding zeros on to the front, it's all about moving that decimal point the correct number of steps and filling in any blank spots with zeros. All right. Does anybody have any more questions about our metric units or how to convert between bigger and smaller or smaller and bigger units?
I'm still a little confused, but yeah.
Do you know which part you're a little confused on?
I would say just like the breaking it down. Um, honestly, I came in a little late.
Oh, okay. No worries. So let's see. We'll use blue. Go back to blue. So the first thing to do is always figure out your starting units and your ending units. So you'll always be given some number of starting units, like this guy right here, and ending units. So your starting units could be things like kilo something. So this would be kilograms or kilometers. So if it looks like that, it's going to be in the kilo box. Our base units are meters and grams and liters. And then over here, you could have centimeters. And over here, you could have milliliters or millimeters or milligrams. So the first thing is to identify what is your starting unit and what is your ending unit, whether that's kilometers and millimeters or grams and kilograms or milliliters and liters or centimeters and meters. You're always going to have a starting and ending value. So once you figure out where you're starting, like in this case, we started at kilometers and ended at millimeters. So once you do that, you then use this ladder. And also I posted in the Google Classroom as well, a picture of just the ladder next to the notes that we went over today. And I'll show you guys that in a second. So that you can go back and find a copy of that ladder really easily if you ever need to. So you come to your unit ladder over here and say, all right, I'm starting at the kilo. And in this case, I'm ending at the milli. And then you're going to take steps up or down the ladder in order to get from your starting point to your ending point. In this case, we're going down the ladder. We're going from a big unit to a small unit. And so you're going to hit every step on the way. Like there's step 1, step 2, step 3, step 4, step 5, step 6. So it took me 6 steps to go from kilometer to millimeter. And it was 6 steps to the right. So that's kind of the easier part. The trickier part is doing that with your decimal number right here. So we started off with 218. And then we moved 6 to the right. So I'm going to move this decimal point 6 spots to the right.
Okay, okay.
1, 2, 3, 4, 5, 6. So we made 2 jumps past the 1 and the 8. And then the remaining 4 jumps are these blank spaces. And like we said a second ago, we'll fill in those blank spaces with zeros.
Okay, okay.
So 2.18 turns into 2180000 and then the decimal. All right, did that help a little bit, Amber?
Yeah.
All right, awesome. So let's see, we're gonna jump back to our classroom here. Here we go. All right. Hopefully that you feel pretty confident and comfortable with that conversion stuff, because you're going to be doing a lot of it for the Wednesday night homework tomorrow. So like I said, besides the full set of notes that's posted up in the Google Classroom like normal, under today's notes page, there is also this one single set of notes that's just this units ladder. So if you ever want to have an easy way to go back and find just the ladder that shows all the units laid out from kilo to milli, you can find that posted in today's notes section next to the normal slides. So today's homework, pretty simple and straightforward. It basically just has to do with those different types of metric unit we were talking about at the beginning of class. So the first part is I give you a abbreviation like this, and I want you to tell me what type of measurement is described by this. Is it length? Is it mass? Is it volume? Or there's one more that we didn't really talk about today of time, but that's because time works the same no matter where you are. There's not like a metric or an American system of time. Everybody in the world uses seconds, minutes, and hours to count the time. So I didn't really go over it today because it works the same no matter what country you're in. So I wanted you to tell me, is ML length, mass, time, or volume? Or what is G stand for? What does MM represent? What does big L tell me? Is it length, mass, time, or volume? So that's the first part of that. Up next, I want you to do a little bit of the reverse and tell me, based on the name of a unit, what would its symbol be? So would milliliter be MM or kg or big L? And then what about centimeter? What about gram? So on and so forth. And then finally, for the last part, I give you some kind of everyday scenarios, and I want you to tell me what measurement would fit best in here. So colas may be purchased in 2 or 3 what-sized bottles. About how heavy is a bowling ball? About how long is like a fly? About how heavy is a paperclip? About how wide is it if you stretch your arms out to either side? So all you have to do is fill in these blanks with the correct sized unit. All right, so a lot of questions, but very short and simple ones for today. Tomorrow is a little bit more complex. Essentially, it's just a whole bunch of those conversion examples like we were doing earlier. So I give you 160 centimeters. I want you to tell me how many millimeters. I give you 14 kilometers. I want you to tell me how many meters. I give you 198 grams. I want you to tell me how many kilograms. I give you 355 milliliters. I want you to tell me how many liters is that, and so on and so forth. So there's a lot of them, but once you get the hang of it, it's pretty easy to get through these pretty fast. So today's daily assignment is all about just the actual names and types of measurements. Tomorrow's assignment is going through those conversions. And again, if you need it, especially for tomorrow, that units ladder, you can find it posted right here in the Tuesday notes section of the classroom.
Awesome, awesome.
All right. Anybody have any final questions about metric units, conversions, or the daily assignment for today or tomorrow?
No, sir.
Let's see. There we go.